Welcome to Captain of Industry's Advanced Train Guide. Our previous video covered the basics, but here are 10 tips that will get the most out of our train system. Tip 1. Rail placement. There are two main principles to keep in mind when building your network: curves and slopes. Steep turns limit the maximum speed of trains. As you lay track, pay attention to the color of the placement guide. Blue indicates no speed penalty, while yellow and red show increasingly sharp turns that will slow trains down. You can set the minimum track radius by pressing F when placing tracks. Trains perform best on flat tracks, maintaining full speed and efficiency. When elevation is necessary, for example, to reach a higher platform or cross over other tracks, it's beneficial to build gentler slopes that minimize speed loss. To control how steep the incline is, use the J hotkey to toggle between the maximum grade settings when placing elevated lines. Long trains can run into issues on steep slopes. Before building, check the train speed section in the train designer window to make sure that it will be able to handle longer climbs along your line. Tip 2. Crossing rail tracks and elevated rails. The easiest way to allow vehicles to cross train tracks is to use level crossings. To build it, first build the crossing train track piece and then the entrance and exit gates. You can also use the connector piece to build longer crossings that span multiple tracks. Level crossings come in two sizes: a small one, which allows the passing of small and medium vehicles, and a large one for mega excavators and haul trucks. In high traffic areas, it may be beneficial to build an elevated rail instead of a crossing to avoid trains blocking vehicular traffic. You can raise or lower rail segments using the Q and E keys while placing track. Most vehicles need clearance of 4 tiles, so that level is recommended for elevated tracks. But if you need mega excavators to pass under elevated train lines, you can excavate an underpass. Tip 3. Train length and efficiency. Don't be afraid to make longer trains. They are more efficient. By extending a train from 4 to 8 wagons, the throughput is nearly doubled while the fuel and maintenance costs stay roughly the same. Train depot extensions can be added onto depots to build even longer trains. A train with 8 wagons has the same throughput as 5 haul trucks, 12 medium trucks, or 36 pickup trucks, all while using less fuel and maintenance of a single haul truck. For the same throughput and distance using conveyor belts, the maintenance cost is roughly triple the amount of our train. Just keep in mind that the belt uses electricity while trains require fuel to move cargo. Longer trains can be utilized no matter the size of the station because of our continuous loading and unloading system. And carefully placed no stopping zones will ensure that they do not jam up your network. Tip 4. Fuel stations. Trains will always refuel if there is a matching fuel module at a station they are servicing. You can make a dedicated fueling station that trains will only visit when their fuel is low. To do this, add a stop with a fuel station to your line and then check this box. Now this stop will be skipped if the train does not require refueling. You can even add multiple fueling stops into one group, and then the train will choose the closest station. It's your choice to have a centralized fueling station for all trains on your network, multiple dedicated stations along longer lines, or just refuel while loading or unloading at any given station. And don't forget, add tenders to your steam engines for extended range. Tip 5. Arrival and departure conditions. Train behavior can be fine-tuned by using arrival and departure conditions. Departure conditions are configured in the train lines manager, per stop on each line. These control how long a train stays once it arrives. You can use options like waiting until a train is full or empty, or wait a certain amount of time before departing. Let's say we have a train delivering acid to a remote copper plant for electrolysis. By setting the departure condition to wait until the train is empty, we prevent unnecessary trips which can waste maintenance and fuel. If you have multiple stations in a group, make sure to have their departure conditions set for each station. Arrival conditions are configured per station and determine when a train is even requested. For example, setting a station to only request a train if all modules are full ensures trains are only dispatched when there's a full load ready. This avoids trains waiting to be filled or partially filled trains. In another example, let's say you have a slag pickup station near a copper smelter. Slag is produced intermittently, so setting the arrival condition to only request train if all modules full prevents unnecessary trips when there's just a trickle of material. Tip 6. Station groups and cargo distribution. Station groups let you combine multiple platforms into a single virtual stop, giving trains flexibility to pick the best available destination. To create a group, open a train line, click the Station Grouping button, and then select other station platforms you want to include. Trains assigned to the group will automatically choose the closest available platform that meets all conditions. This is useful for stations with high traffic. You can set a train limit per station to control how many trains are allowed to head towards it at the same time. This prevents too many trains from servicing a single station, which could block junctions or sidings. Remember that depart conditions are set per station, not per group. Set conditions manually at each station if you wish to have all stations behave consistently. Station groups can also be used for centralized distribution. For example, a diesel supply hub can provide fuel for multiple stations. Set each destination station to request train if all modules empty, and set the train limit to 1. Then add them all to one group stop. This ensures that trains only leave when fuel is actually needed. You can do the same thing for centralized collection, gathering slag or waste rock from multiple remote sites and bringing it to one processing location by using the if all modules full precondition. Tip 7. Wagon product filters and line manager filters. When your station handles more than one product of the same type, for example, iron ore, dirt, and rock, it's important to control what trains pick up and where. Line filters are applied per stop in the train line manager. They define which products a stop is allowed to load or unload, regardless of what the station has in storage. For instance, setting a line filter to iron ore at a multi-material station ensures the train picks up only iron ore, even if other materials like rock and dirt are also available. This is great for global line control, ensuring a train dedicated to delivering iron doesn't accidentally load additional and unintended materials from the same facility. If you need even finer control, use Wagon product filters. These are set per wagon and define what each individual car is allowed to carry. You can assign one wagon to iron, another to rock, and a third to dirt. When the train arrives, it will only load those materials into their designated wagons. Use line filters for broad stop level control and wagon filters for precise train level behavior. But try to avoid overlapping these two filter methods when possible. If line filters are sufficient for your needs, wagon filters are not required and vice versa. Decide what is best for your network. Tip 8. No stopping zones. No stopping zones are track segments where trains are allowed to pass through but not stop. A train can only enter if it can clear the entire section. These zones are automatically placed at intersections and marked with red stripes on the ends of the ties. They can help prevent trains from blocking each other and keep traffic flowing through busy junctions. On the other hand, you are able to manually add a no stopping zone when a stopped train could block multiple paths. Roundabouts are a common example. If a short train stops in the middle, it can paralyze traffic trying to enter or exit from other directions. You can also use no stopping zones in shared corridors between train lines to prevent one stalled line from halting the entire section. There are times when you can safely remove a no stopping zone. For example, if two tracks merge and no other junction follows immediately, it's usually safe for trains to wait there. Another safe scenario is when a split leads to two diverging tracks and a stopped train won't interfere with anything behind it. As a rule of thumb, if you ever find a train blocking others from moving forward, that section should likely be marked as a no stopping zone. Tip 9. Exclusive zones. Exclusive zones ensure that only one train can occupy a given section of track at a time. They are marked by blue stripes across the ties and are automatically applied to all bidirectional tracks. When multiple exclusive segments are directly connected, they act as one continuous zone, so even unrelated tracks can be blocked if joined in properly. There are times when exclusive zones should be removed. This is often necessary when connecting a double-track mainline to a terminus station using a short bidirectional segment. If the segment and all station lanes share a single exclusive zone, only one train can use the entire complex at a time. In these cases, remove the exclusive zone, but always replace it with a no stopping zone. Leaving bidirectional track sections with neither can cause trains to meet head-to-head with no way to recover. You can also use exclusive zones to enforce clean traffic flow through staging yards, sidings, and approach tracks. For example, if you want each train to have its own buffer lane before a busy station, exclusive zones prevent two shorter trains from crowding into the same lane. Plus, you can hold shift while using the no stopping and exclusive zone tools to quickly apply the setting to an entire segment. Tip 10. Efficient station building. Stations come in two main forms, row and terminus, each with their own use cases. Row stations, short for roll on, roll off, allow trains to enter from one end and exit from another without reversing, making them ideal for high throughput routes. For multi-lane stations, avoid placing X crossings directly in front of the station, as these can block multiple tracks when a train passes through. Instead, use clean through lines with buffer tracks before the station to prevent trains from backing up while waiting. Terminus stations are simpler to build and work well in tighter spaces or on low traffic routes. Trains enter and then reverse out. Be sure to leave enough space after the terminus station to allow the train to pull forward so all the wagons can align properly with their station modules. When connecting stations to your main network, layout matters, especially when mixing row and terminus types. A single line terminus can connect via a basic T-junction. To improve flow, add a siding or buffer track so reversing trains do not block the main line. To keep traffic flowing smoothly, place row stations as sidings that run parallel to the main line, matching its direction. This ensures that arriving and departing trains don't cross paths, reducing congestion and improving throughput. You can even chain multiple row stations one after the other. Avoid routing both the entrance and the exit through a single intersection. This forces trains to cross paths and can create congestion. Also, avoid placing forks immediately after a station. While unloading, the train may need to pull forward to align wagons with their assigned modules. During this movement, it will not be able to choose a fork because it does not know where to go until unloading is complete. You can also build dedicated reverse spurs, which act as turnaround zones where a train can perform a 3-point turn after leaving a terminus. To create one, place a track segment long enough to hold the train with a single station added to its schedule. The train will reverse into this section and then leave going forward back along the route it came. You've now seen 10 advanced techniques to improve your rail network, from optimized layouts and filters to smart fueling, routing, and train behavior controls. We hope these tips help you build faster, cleaner, and more reliable logistics to keep your settlements running smoothly. Thanks for watching, and as always, good luck, captains.